This lesson is about the shearing facility built into the affine transform class. It may not be as dramatic or even as interesting as some of the other facilities, but you should know about it because it can come in handy. It's actually more useful with photo images than with polygons, but it's easier to show how it works with a simple polygon. The shearing method of the affine transform produces a skewed result of the image. You can skew the image along the x-axis or along the y-axis. I came across a description of shearing somewhere, I don't remember where, that does a good job of describing what happens. If you take a pencil and draw a picture on the edge of a book or a stack of paper, and then slightly skew the pages of the book so the figure becomes sort of tilted or skewed, that is shearing. This program demonstrates the three fundamental ways of shearing. You can shear along the x-axis, along the y-axis, or along both at once. Now, this loop is for drawing 3 rows of figures, each one of them showing progressive degrees of shearing. This is the variable that's used for the shearing value. As the loop counter goes from 0 to 9, this value will go from 0 to 0.9. A 0 shear value has no effect, while a value of 1 is the maximum shear. This variable sets the horizontal position of each figure as it's drawn, so they'll be progressively more and more sheared as they move from left to right. This is the first row of sheared figures. The call to the shear method here only has a value for the x-axis, so shearing only occurs horizontally. The y-axis shearing value, the vertical shear, is always 0, so there is no vertical shearing. This is for the second row of figures. In this one, the horizontal shearing value is held at 0, while the vertical shearing is varied from 0 to 0.9. This last row of sheared figures are skewed along both the horizontal and vertical directions. Here's what it looks like. Here you can see the top row is slowly shearing along the horizontal axis as the shear value increases. Remember that the origin is at the very center of this polygon, and because the shearing value was set into the transform last, it's actually done first. So that means the figure is sheared to the right below the origin and to the left above the origin. In the second row, the shearing is in the vertical direction. So it's up on the left of the origin and down on the right. The last row shows the results of shearing in both directions at once. As you can see, too much shearing in both directions simultaneously tears the figure apart. I've shown you all the basic functions built into the affine transform object, and they can be used to do most of the things you want to do. Affine transforms can also be used to do some other things, but to do them, you'll need to know how the transforms work so you can set up your own. And that's the subject of the next lesson.